Good afternoon, good morning, or good evening, and thank you for joining us today at our hardware webinar. Before we get started, I just want to make sure that everyone can see me and can hear me. We have David Grover over in the UK moderating, so if there's any issues, give David a shout and he might be able to help you out. And throughout the process of the entire webinar, just make sure that if you need to resize a window, you do so. We'll be able to show you the XF camera system here in the studio through the webcam, so you can resize that window. And we'll also be able to show you Capture One software through the screen sharing, and you can resize that so you can see the results that we're talking about as we go through the process. So, my name is Drew Altdorfer. I am a product manager here at Phase One, and I am happy to bring to you today a hardware webinar that is going to focus on hyperfocal focus and calibration. Now, in the advertisement, we talked about having the wide-angle lenses, and we're using a wide-angle lens because we're inside a studio, and we're going to be talking to you about depth of field, infinity focus, hyperfocal focus. Those are all things that are really hard to do in a studio with a traditional lens, so we're using a wide-angle lens really to just illustrate to you the tools that I'm going to go over. So we're in a rather sizable studio, but we have at one end of the room, we have a print, a beautiful landscape photograph that's going to represent our proxy for infinity focus. And then we have a focusing chart that is going to be our foreground. Now what I'm going to do today is just walk you through the hyperfocal calibration on the XF camera system. We'll do a hands-on demo of that calibration here in the studio, and I'll go through a couple of the terms that we'll talk about and kind of the technical aspects of hyperfocal focus that you need to be aware of as you go ahead and do this on your own XF camera system. So if nobody has any issues, then David, say hi to everybody and let me know we're good to go.
Hello, everybody. Yep, we're good to go, so carry on, Drew.
Fantastic. Thanks for that, David. Always good to hear your voice. So, we're talking about hyperfocal focus. So what is hyperfocal focus? Well, this diagram that you should see on your screen is one that's lifted straight out of the manual. So what is hyperfocal focus? It's achieving maximum depth of field for a given aperture, but that's depth of field in the foreground as well as the background. Now, a lot of people will say, well, that's easy. You just stop down to f22, f32, and you'll get maximum depth of field. But the trick with hyperfocal focus is that when you focus at infinity and you stop down, you're wasting a lot of depth of field behind your infinity point. So finding the hyperfocal focus is actually shifting the focal plane forward so that your depth of field shifts with the focal plane and you still maintain focus at infinity. So again, infinity is in focus without focusing at infinity. So you still maintain infinity focus, but you're not focusing the lens at infinity. You're focusing the lens at a point closer to you, but maintaining all that sharpness and moving at depth of field closer to you, and the foreground subjects then become sharp. So, for starters, just so everyone knows about what I'm talking about, you've all seen this little diagram here. This is your hyperfocal focus guide that's on all the lenses. It's been on all the lenses for a very, very, very long time. And what this guide is illustrating to you is the acceptably sharp range of your depth of field for a given aperture. So in this particular example, this is just the stock 80mm blue ring lens photograph. And it shows that at an aperture of f16, you would expect to find sharpness between 2 meters to 4.5 meters in distance when you're focused at 2.75 meters. So that's what that guide is giving you, but you have to keep in mind that that guide is an approximation, and it is a legacy guide brought over from the film days. It hasn't changed much from the days of the very first SLR lenses. So when we get into the high resolution of digital backs, it becomes less and less scientific and more of an approximation. It is a very good guide to give you an idea of what you're working with, but the hyperfocal calibration in the XF is designed to give you absolute precision in terms of finding a hyperfocal focusing point. So again, they're legacy from the film days, so you have to give them a bit of forgiveness. Now, I said it's a guide to demonstrate to you what is acceptably sharp. So what does acceptably sharp mean? Acceptably sharp means that it is a bit of a objective or subjective opinion as to what is sharp, because it's all going to depend on your final output for the image. Everyone knows that depth of field does not start and stop in an image. The image gently rolls into focus and then rolls out of focus. And so that kind of start and stop is where we have that ambiguity. What is sharp? To some people with excellent vision, on a very small print or very large print, it's going to look different. They're going to say that is definitely in focus. It's a perfectly shot image with absolute fantastic hyperfocal focus, whereas somebody else might argue with them. So that acceptably sharp is a gray area in terms of what is perfectly in focus. So if you want to know more about that acceptably sharp term, I would encourage everybody to just go ahead and do a couple Google searches for the circle of confusion. The circle of confusion is a term that is the scientific breakdown of that approximation, what is sharpness, in terms of depth of field. It is not covering all of acceptably sharp, but it is a very crucial element to what acceptably sharp means, and they overlap quite a bit. So if you want to learn more about that ambiguity, I would suggest you go ahead and do a little bit of research on your own. It's a bit more of a conversational topic that I don't think is fair to anybody to get into on a one-way webinar. Another illustration just to demonstrate and hopefully just drive home what it is we're going to be doing today with the hyperfocal focus and calibration. So at f16, you'll notice between these two images, the blue represents our depth of field. If we were to focus our lens using f16 at infinity, the mountains would absolutely be sharp. That's what the camera's designed to do. I pointed the camera at the mountains. I said autofocus. It focuses at infinity. The mountains are sharp. And I take that image and I'm happy with it. But what I'm missing out on is all the depth of field that I've wasted beyond infinity. All of that blue area beyond infinity is depth of field that I'm not taking advantage of. So by finding my hyperfocal focusing point, which is closer than infinity, I'm actually shifting all that depth of field so that I get my foreground in focus. In this case, there's some beautiful trees, beautiful mountains, and if I use my hyperfocal focus, one that I've calibrated in the XF camera system, I'm able to achieve nice sharp focus, acceptably sharp focus, from the foreground all the way to the background in the mountains. So you're really shifting your focus, and the depth of field remains exactly the same, but you're just moving the actual focal plane forward and therefore shifting your depth of field forward to encompass all of your subject matter. So if you joined our webinar last month, you'll notice that I'm shamelessly recycling a slide, and this is just to illustrate depth of field. Depth of field, everyone knows what depth of field is, of course. The wider your aperture, the less depth of field you have. The smaller your aperture, the more depth of field you have. But again, it's important to reiterate that when you get into smaller apertures with high-resolution camera systems, you begin to introduce diffraction, which then appears soft in the image. It's not a missed focus. It's not a broken camera. It's not a manufacturing default. It is a result of high resolution and that image going through a very small opening and being projected onto a high resolution digital back. So just to point out the emphasis again on depth of field, if you're looking for maximum depth of field without introducing diffraction, you're going to be looking somewhere in between the f8 and f11 range for almost all of the Phase 1 products, from the 60 megapixel digital backs up to the 101 megapixel digital backs. So again, this is important. That's why I emphasize it yet again. In diffraction, you'll notice that these two images, and I have the bigger example on the next slide, these are shot with the exact same focusing point. The hyperfocal focus was found on this particular lens camera combination. It's somewhere around 15 feet. And in f5.6, I'm able to get tack sharp images from my foreground all the way to infinity when I find that perfect hyperfocus focusing point. Now, common sense would tell me if I want more depth of field and I want to be absolutely sure that everything's in focus, I would stop down to f22. But in doing so, I introduce diffraction. So my focus has not shifted from the image on the left to the image on the right. The only thing that I've changed is my aperture. And the image that's shot at f22 is very, very soft. That was shot with a 101 megapixel digital back, the IQ3-100. And I do get soft results if I use f22. Really, anything above f11, I'm going to see a slight softness. But it all goes back to what is acceptably sharp. Given the subject matter, given my distance to focus to that subject matter, given a whole bunch of different factors, including what is my final output size. I need to really understand what is acceptably sharp to me, and that is a subjective opinion. depending on all the different factors of your exact requirements. So the balance when you're looking into hyperfocal focus is finding an aperture that's going to give you a lot of depth of field but not introduce diffraction. You have to find, the balance between those two. I want as much depth of field as I can. I don't want to introduce diffraction. Where am I focusing in the scene? All of those things are going to, come together to ensure that you're applying the right hyperfocal point to that specific lens on your XF camera system. So, what is hyperfocal calibration? Well, hyperfocal calibration is a tool within the XF camera system that we've designed to help you find this exact point in the lens, the exact point in which your lens should go to, and still give you sharp results at infinity with as much of that depth of field shifted into the foreground. That's what the tool is designed for, so that you can, through a system of manual calibrations and feedback loop through Capture One, find that perfect focusing point. Infinity stays sharp, my focus is moved into the foreground. So we do recommend that you use Capture One with it. You're of course not required to, but Capture One does allow you to look deeper into the images, kind of pan around a little bit easier, and it also, in Capture One, gives you the metadata when you're using this calibration tool to tell you exactly where the lens is, what is my focusing position of the lens. For us, that's called an MCU, and it's represented by a static value on the XF camera system. And I'll show you that when we do the demonstration. So the calibration tool allows you to save that exact position. Once you do the calibrations and you find this point gives me the perfect focus to infinity, all of my foreground, this is where I want the camera to go to each and every time I invoke the hyperfocal focus. You can save that value into the XF camera system. And you can actually, I keep saying that you want to have infinity focus because, again, that's what the lens is designed for. But this tool can be used for almost any application where you want the lens to return to a specific point. So it's called the hyperfocal focusing tool and hyperfocal focus. And we are going to be going through a hyperfocal calibration. But keep in mind that really this tool, when you boil it down to the simplest terms, is simply a way for you to determine that the lens returns to a specific point on its focusing ring. That's all it is. So in that regard, it can be a sweet spot saver, which means if you're doing tabletops in the studio and you always want the lens to return to the exact same location in its actual focus and always focus right on the tabletop, then you can save that using the hyperfocal calibration tool, and that'll be your lens's sweet spot for that specific setup. If you're shooting portraiture and you have a model that's moving a lot, you can use autofocus, but if you find that you just miss autofocus every now and then, but the model's kind of in the same general area, well, you can figure out what is my depth of field given this aperture, where should my hyperfocal point be, and you can save that on the fly in the camera and always have the lens return to that exact location. So sports photography, for example, this is a very great tool for sports photography if you're going to pre-focus. Because if you've ever tried to use the workflow of pre-focusing, you'll sit there and you'll focus on something and say the athlete's going to be in that position in just a moment, and I want to make sure that I'm focused exactly at that spot. And then what inevitably happens is once you've manually focused your camera to that exact spot and you're waiting for something to happen, something else happens, you use autofocus and you capture that shot, and then when you have to go back and start the whole process over again. With saving a sweet spot using the hyperfocal tool, you can focus on that exact location, save that exact focusing point on the lens, save it into the camera, go about your normal business, and then once that athlete comes to that exact point, invoke hyperfocal focus, the lens will go to that exact spot, and you can take your shot knowing that the lens is going to the exact location that you've saved in the XF camera system. So it's not just a tool that you can use for, that you have to use for landscape and hyperfocal focusing. It can be used in other applications. Now, keep in mind, for this particular example, I am going to treat it as though it is a landscape because that is the simplest way to describe the hyperfocal focus and its benefits, and of course, the simplest way to really demonstrate it for you here in the studio. You can save one hyperfocal point per lens, and the hyperfocal point is not intelligently integrated to your aperture. So when you do a hyperfocal calibration, you really want to keep in mind, again, what aperture am I going to use. It's going to give me the maximum depth of field without introducing diffraction, which aperture performs best on this specific lens using this specific resolution digital back. These are all things that you're going to have to find through trial and error and experimentation. But once you find that one aperture, you'll need to know every time I invoke hyperfocal focus on the XF camera system, I need to make sure that I'm using that aperture, otherwise the results may vary. So, I'm going to briefly go over the setup, but again, I'm going to repeat a lot of this when we switch over to the overhead camera of the XF. So how am I going to go about calibrating the autofocus? This is the actual tool, the hyperfocal focus tool, and it's a calibration tool. This tool does not need to be on every time you want to use your pre-saved hyperfocal focusing point. This tool is in the camera to help you calibrate and find your hyperfocal focusing point. So we do recommend that you shoot tethered to Capture One, again, as we're going to do in this demo. And be sure to reference the description in the metadata that shows you the lens position, the MCU position. And I'll be sure to outline that for everybody when we do the demonstration. The hyperfocal focusing tool, because it's a calibration tool, is not one that's immediately accessible through the swipe menu of the XF or through any of the touchscreen shortcut buttons. It's actually in the menu itself. So you have to go to the camera menu, the tools, and then choose the hyperfocal focusing tool. This tool you can put on the swipe screen if you're using it constantly, but just by default it's kind of buried in there because it is a tool you're going to use for calibration, and it's a once and done kind of calibration. I'm going to use the tool once in a specific setup using the specific aperture. I'm going to find the hyperfocal focus, and I'm going to save it, and then I don't need that tool again unless I want to recalibrate, calibrate a different lens, or kind of just change the way the tool works. The tool has here several different values that are represented. So hopefully, just to clarify these for anybody that's curious or confused, these gears here and the value next to it tells you exactly where the lens is in its actual focusing ring, where the focal plane is. So that value 105 will correspond differently on different lenses. On a wide-angle lens, a value of 105 will be almost at close focus, whereas if you put this on a 120 macro, a value of 105 will only move, a nudge away from infinity. So it all depends on the actual lens that's on there. This is not an absolute value. It is not universal to every single lens that is on the camera. It is specific to the lens. And it all depends on how much precision the lens actually needs. So the longer lenses, like the 120 all the way up to the 240, those need a lot of precision. The slightest bit of movement is going to change where the focal plane is. Whereas when you get into the wide angles, they're a bit more forgiving because they have, they don't have a lot of travel. Your focus is really from 2 meters or 1.5 meters to infinity is only a movement of about, that much. So that value is where the lens is currently. We also have this value of 0. This is the saved hyperfocal focusing point. So in this case, the camera has no hyperfocal focus point, so it just has a value of 0. 0 represents infinity, which means that the lens is all the way at infinity, so that's 0, and that's what's in that specific lens in this example. We have a infinity symbol up here, and that corresponds to the top front key. And that top front key, if you push it, the lens will go to infinity or go to the saved hyperfocal focusing point. We have a little save icon, a bit dated, but the floppy drive save icon, and that corresponds to the rear top key. So once I find my hyperfocal focusing point and I want to save it into the XF, I simply push that button and that value will be reflected here, overwriting any previous values. You'll notice I have 2 small cogs and a X1 value up here. That corresponds to the front dial, and that means that I'm moving the lens by 1 MCU. So 1 motor control unit, a very fine and precise movement, pretty much not noticeable to anybody between 1 and the other. It takes a couple of them put together to really see the differences in the results. Then I have some small cogs and an X10, and again that corresponds just to the rear dial, and that's moving the lens at an increment of 10 MCUs per click of the wheel. Now down here I have something called step with a value underneath it, and when we do the calibration, what the calibration is actually doing is taking one shot and then moving the lens by a value of 5 MCUs, taking another shot, moving the lens, taking another shot, and it'll do this for 5 images. So each image will have a step value that you define between each of them. Why this is important is once you have that sequence of 5 images and you can see the measured difference between each image, you can review it in Capture One and decide which one is best. The value of where the lens was will be in the metadata. You plug that value back into the XF camera system, and then you start the process again to refine it. So the dial that's typically there for ISO is where you can change how big the steps are. And with any calibration, it's always good to start big and refine as you go. And then this little icon here relates to the rear button, and that's to execute the calibration. And again, don't worry if you didn't catch all of that. I'll go over it on the camera in just a moment. So if we were going to do a lens calibration or a hyperfocal focus calibration, and the lens's current position was at a value of 50, and we had an MCU deviation of 5, and we hit that rear button to execute the calibration, we would end up with 5 images with the lens position at 40, 45, 50, 55, and 60. That would be our first sample for the calibration. So the method is pretty simple. Tether to Capture One. Use Live View to start the focus. Now, if you're tethered to Capture One, you can just turn on Live View. You can find a focusing point that approximates, okay, well, my infinity's in focus, and I think I moved it away from infinity and close to the foreground, but I'm not really sure. You can use Live View to really start there and get yourself a good starting point. Set the MCU deviation. So again, that's this value here, the step value. You want to set that to a higher value, 15 or 20, depending on the lens. If it's a long lens, like a 240, you probably want to start at 20, maybe even 30. If it's a wide-angle lens like we're going to use here in the studio, using something like 5 or 10 is going to be a perfect starting point. You'll do the calibration test, review the images in Capture One, take the value that you find to get the best results, take that MCU value, put it back in the XF, and then change the step value, turn it down a little bit, and repeat the process until you're to a value of 1. Once your step value is to a value of 1 and you're doing the calibration at a value of 1, you'll very easily be able to see which one is the best, because you won't be able to tell the difference between it and the ones on either side. So that's going to give you the best results. And if none of this is making sense, don't worry, because we're going to go over it. So this particular image is shot with an 80mm blue ring lens using proper hyperfocal calibration. And as you can see here in the 100% zoomed in samples, the close focus is perfectly sharp, infinity is perfectly sharp, and the entire image from the very beginning to the very end, perfectly sharp. Now it's cheating a little bit because I didn't have anything within about 2 meters in front of me. So if I did have some tall grass just in front, that would probably be out of focus. But given the subject matter, that's the perfect hyperfocal focus. Getting infinity in focus in all the foreground. No need to stitch and pile things together or get tricky with Photoshop sharpening to get all the detail from the very beginning to the very end. And that's what we're after. So with that in mind, I will swap over to the actual camera, and I will bring up Capture One for you guys. So just so you have an idea of what we're working with here in the studio, that is our amazing studio shot there. We have a beautiful print that is representing our infinity, and we have a lens focusing chart that is going to represent our foreground. So with the XF camera system set up, this is not exactly default, and I'll show you the menu options that I've changed when they're relevant. But this is what you should see on your XF by default. And if you go into the main menu, and you go down to Tools, and you go down to Hyperfocal Point, and into that field, this brings up the Hyperfocal Focus Calibration tool. So you'll notice that the value of where the lens is currently is a question mark. So if I touch that question mark, the lens finds a value, and at this point it's 9, which means it's 9 MCU values off of infinity. What that means is very simple. It's just a slight nudge away from infinity. And this is just an arbitrary point that the lens found. It's the first one it could find and verify when I push the button. So in my particular case, I'm going to start off fresh, and we'll start with a value of 10. And so that's our step value. That's going to be the difference between each image. Now, as you can see in Capture One, I have the lens align lens align focus chart, and it's about, I would say, 1.5 meters away from the lens. So I'm just going to go ahead, and if we move, this is our focal plane. If we move that focal plane to about that location, that should give us proper focus. So when I put the lens back in autofocus, it just quickly tries to get me as close as it could. And now I'll just refine that position using the dial. So I'll move in a value of 10, and now I'll move in a value of 1. So that's about where we want to be. So this is now in a position of 85. The lens is at a position of 85 there. And I'm going to go ahead and start the calibration process using steps of 10 between each capture. So as the results come into Capture One, I'll go ahead and once all 5 of them are in here, I'll zoom in and show you guys where we're going to start looking to find our sharpness. So I'm just going to go ahead and hide our tools. And we have our metadata over here on the side. So you'll notice that the images have this small icon down here in the lower left. And that small icon means that these images are part of a sequence. Capture One knows that I used a sequence tool, in this case the hyperfocal calibration tool. And so it marks them accordingly so I can easily identify them. If we look at the actual image, the first one, we can see in the metadata that I have a sequence info, sequence ID, and I have the first of 5 images shot for hyperfocal. Now if I go down into my IPTC data, I have a lens position at 65. So remember, we started at 85, which will be the 3rd image shot. So this is 85, 75, 65. And then if we go back to 85 and forward, we have 95 and 105. So these are the different steps, and again, it's showing you the different positions that the lens is in. And while we were doing that sequence, you could have seen on the webcam, the overhead webcam, you could have seen the lens move incrementally with each shot. So if we just zoom in at 85, and we'll zoom into 100% in the middle. And remember, we're using this as an approximation for what infinity focus would be and how we would use the tool traditionally. If we zoom in to 85, we'll notice that infinity is in focus, right? Our mountains, our trees, everything is beautiful and in focus, nice and sharp. That's what we want to see. And our foreground, this focusing test chart, is a bit soft. Now, there's some of it that is arguably in focus, quote unquote in focus, but it's a bit soft. If we go to 75 and look at the exact same area, we'll notice that infinity is sharp, but we've lost all legibility on our focusing chart. So if we go to 65, we should again see that our infinity is nice and sharp, but again, our foreground is going out of focus. So this example here is one that would really be similar to shooting at infinity focus, where our mountains are nice and sharp, but we've really lost anything in our foreground. So we have a very, very beautiful, sharp, crisp, clean infinity focus, but we have no advantage to our depth of field in the foreground. So if we go back to 85, and we go forward to 95, we'll notice that our focus is getting much better. This is getting much more legible, but we need to then compare that against our infinity focus. So if we keep walking to 105, and we compare 105 to 85, with 95 in there, what we should see is this is 85. We have some sharp details here at infinity. And if we just scan up here, we should see everything is nice and sharp across all of these, but we start to lose it at 105. So that means we're moving in the wrong direction. So infinity is no longer in focus when we look at our image shot at a value of 105. So now we've moved our depth of field too far forward. So we can get rid of 105. We know that is right out. There's no way that 105 is going to be a correct hyperfocal point. But now we need to compare 85 to 95. And when you look at infinity, it's going to be very, very difficult to tell the difference. So then let's see what we're gaining between the two. So between 85 over here on the left and 95 on the right, it looks like we're gaining a significant amount of foreground focus. So in this particular case, you can read all of the characters down here on the actual focus guide, whereas if we go to 85, just so you guys can see, those are not legible, not sharp. So we've gained quite a bit of focus in the foreground, but if we again go back to our infinity focus, have we lost much focus at infinity, if any at all? There's an argument to be made, again, what is acceptably sharp, that we have lost a touch of infinity focus. But what we do know is that between 85 and 95, again, a lens position of 85 over here and 95 over here, between those two is going to lie our hyperfocal focusing point. So, from that example, we'll go back over here to the camera. And we are at 85, and we know it's going to be between 85 and 95. So we're just going to go 5 steps forward to a value of 90. Notice very small adjustment between 85 and 90. And we're going to move our steps down. We'll use a value of 3. So this will shoot 6 steps under, 3 steps under, neutral, 3 steps over, 6 steps over. So we'll go ahead and execute that. And this is the refinement process of the actual calibration. You shoot one at a larger deviation for the lens, and then you compare and refine, refine, refine. So this should be our 5th image coming in now. So here we have 96, and if we compare 96 to which should be 84, we'll notice that there is a very significant loss of focus at 96 for infinity focus, which is great, because now we know that we're in the right direction. And if we pan down to our focusing chart, we should see that this is very much in focus. Almost the entire focusing chart is in focus, whereas at 84, almost none of it is in focus. So if we go to 90, this is our midpoint now, and we compare 90 with 87 and 93. This is where we want to first start off by looking at infinity focus and defining what is perfect, acceptable sharpness. So right now we have 87, which is nice and sharp. We have 90, which is nice and sharp. And we have 93, which when compared to the image above it, so this is going to be 93 and 87. When we compare those two, I think it's safe to say that 93 is losing a bit of softness. So now we know that we're going to be somewhere in between these two images. 87 and 90, and maybe on the north side of 90 by just a hair. So what we'll do lastly is we'll go down and we'll refine our steps to 1, and we're just going to push this up to 91. So we'll have up to 94 and down to 88. As those 5 images.
Interject for a second.
Of course, David, always.
Just to let you know, I don't know if you've got the IPTC tool up as a floating window, because GoToWebinar isn't showing it, so it might have to be docked to the side. Or you just want to roughly show where it is. There we go.
I can add it right back in there.
Yep, that's good. Yeah, it's just, I think GoToWebinar was only showing one window, not the actual floating tool as well. So, but there we go. Thank you.
It's nice of them. Thanks, David. Always there. You always got my back. So if we look at the next 5 that we just shot, one, 2, 3, 4, 5. All of these have a deviation of only 1 MCU between them. So if we look at all 5 of these, and these are focused pretty much at infinity, we shouldn't see too much of a difference between all 5 of them, especially when you look at them in a row. So you'll notice that we went from a lens position of 89 all the way up to 93. When you look at them sequentially, you really should struggle to find a difference. But if we just look at the 92 value versus the 89 value, so here we have 89 and here we have 93. This is where we should be able to start to see a difference, which is very, very good because it's a very slight difference. I think you can notice it in these trees a little bit, and maybe in the water and the mountains details here. It's a very slight difference, but it is a difference, which means that our absolute perfect hyperfocal point is going to lie in these 3 images. So in between these 3 images, we have one that is going to have acceptably sharp infinity focus, if not perfectly sharp infinity focus. And then we can determine which one of these 3 has the most foreground focus. So if we look at all 3 of these at 100%, we see that they're very similar, and our infinity focus at the beautiful mountains is absolutely perfect amongst all 3 of them. So now we can compare all of the foreground of these 3 images. So we have a value of 90 here, 91, and 92, and we want the one that gives us the most foreground focus. And it is going to be slight, but it is going to be noticeable. So if we just look at the legibility of these characters here, in the middle between A and B, we can see that they get slightly sharper as we go to 92. So we have a value of 90, 91, and 92. And if we look at our focusing chart, all the way up without argument to 4, I would say, is perfectly sharp, whereas if we look at a value of 90, 0 is perfectly sharp. So that small difference, while we have perfect infinity focus, that small difference in the foreground, in this particular studio environment example, is not going to make that much of a difference, but you can extrapolate the results of this studio test to what you would find out in the landscape. If you were using this in a real-world environment where you had mountains, your focus would truly be, maybe 3 meters in front of you to infinity, not even 2 meters in front of you to infinity. And that's with one shot, one lens, and that does fall under what I would objectively call acceptably sharp. So now that we know that lens position of 91, as shown here, is where we want our hyperfocal focus. Sorry, 92. That was the one with the closest foreground focus. All we're going to do is go back into the XF, go to 92, and hit save. So now that value illustrated there is our hyperfocal focusing point, and that is the sweet spot of that lens. Now, as I said, in this particular studio example, we are cheating a bit, as that isn't infinity focus, but you get the idea of what we're trying to achieve, where we maintain focus at a very distant subject and move our depth of field forward. So now that we've calibrated where our perfect hyperfocal focusing point is, you're going to ask yourself, so what? What are the advantages? Well, now the advantages come in the actual workflow with hyperfocal focusing point, and that point saved in the XF camera system. So because that point is saved in the XF camera system, that camera will recall to that exact location every time you invoke hyperfocal focus. You can do this in one of 2 ways on the XF camera system. You can assign a button where whenever you push this button, no matter where the lens is, as long as it's in autofocus mode, it'll go to that exact position on the lens, your hyperfocal focusing point. Why would this be of value? Well, if you're shooting landscape and you have your hyperfocal focusing point set to infinity and as much foreground as absolutely possible, you don't need to focus your landscapes anymore. You simply get out of the car, set up your camera on a tripod, invoke hyperfocal focus. It goes to the exact sweet spot, the hyperfocal focusing point on the lens, take a shot. Infinity is absolutely going to be sharp, and you'll have as much foreground in focus, nice and sharp, as possible. So, for landscape usage where you are constantly shooting infinity and you want it nice and sharp, it's an absolute time saver, but it also gives you consistency with every single lens that you have. You always know that you're not going to shoot. Oh, I missed focus in infinity. My mountains and clouds were a bit soft. Once you do this test and this calibration and put it back into your XF, they will always be in focus, which is always great too if it's low light, perhaps, shooting the northern lights. You want to make sure that your northern lights are nice and sharp, but it's kind of hard to focus on the northern lights. You might have experienced that where you crank the lens to infinity and hope for the best, and it gets a bit soft because it's just off, or you stop down to f/22 and got diffraction. With this, you can shoot at a wider aperture. You can have it go to infinity focus time and time again without ever incurring autofocus or having to manually focus it on something else. Aerial photography, this is an absolute must for aerial photography, where you want to use autofocus with the XF camera system and point it around, take a picture of XYZ, but once you're shooting straight down, you want to make sure that the lens goes to a consistent location time and time again. You can just invoke hyperfocal focus, it'll go to that exact location, you'll always get sharp images. And really just general use of photography whenever you're using infinity. Now, that's if you assign it to a button. You can also make it an autofocus mode. What does that mean? It means that any time that you invoke autofocus on the camera, you are going to tell the camera to go to the hyperfocal focusing point. When might that be good? Well, if you're shooting in a studio and you're capturing from Capture One, you can simply hit the autofocus button in Capture One software. It'll go to your hyperfocal point. You know exactly where the focal plane is going to fall, and you can take your shot. So there's a lot of different workflows that you can mix and match to take advantage of this value that you've just saved. And I'll just show you the actual workflows of those on the camera itself. So right now, as I mentioned earlier, this camera is not set to default. If we go into the UI setup and we go down to the control setup, you'll see that my shutter half press is turned off. It's set to none. My rear button, which is this button here, is set to autofocus, and my front button, which is the one inside the grip in here, is set to my hyperfocal. So the workflow, let's say I needed to get out of the car and autofocus on infinity, I would simply invoke autofocus. You'll notice that the lens moved to what is, in this studio example, infinity focus. And I'll take a shot. And I'm just going to pull that up in Capture One. So this is the shot that the camera just took when it went to the quote-unquote proxy for infinity focus. And you'll notice, using autofocus, my infinity, my mountains are nice and sharp, but my foreground is incredibly soft. No real advantage to my depth of field there. Now, if I go and I use my hyperfocal point, and I'm just going to push the button on the inside of the grip, and you'll notice here on the lens, we're going to go to that value that I saved previously, and I take a shot. The image that comes into Capture One, my infinity focus is still nice and perfectly sharp. The exact same results as using autofocus at infinity, but what did I gain? I gained all of this depth of field in the foreground. So having it assigned to a button, mixing and matching with autofocus, is absolutely a fantastic way to use the tool. Now, as I mentioned previously, you can set it as a autofocus mode. So if I click on my focus mode in the icon control, I can now choose hyperfocal. And now, whenever the lens and autofocus is invoked, so let's say the lens is sitting down here, anytime I invoke autofocus, it goes to my hyperfocal point. This is very similar to having a separate button set to hyperfocal. In fact, if I push this button, it'll go to the exact same spot. So autofocus and hyperfocal are all going to go back to the same spot. But the advantage of this is that it's an autofocus drive mode. So I can have some flexibility with the buttons that I'm pushing, with the customization that I use on the XF camera system. I have all of these different ways to mix and match the camera's ability to invoke that hyperfocal focusing mode. So just some overlaps in how you can use it depending on the application. But for any of you guys out there that are landscape photographers, calibrating the hyperfocal focus point with infinity focus, as I just demonstrated with those two shots in Capture One, it is the difference between wasting your shot when you get out of the car and having to fine tune with manual focus or focus on something and then shoot back, or just getting out of the car, hitting one button and taking the capture. So an incredible time saver, an incredible tool, and as I've mentioned throughout the webinar, it's not something that absolutely has to be used for landscape photography and focusing at infinity. It can simply be used to save a sweet spot in the lens to go to a predefined focal plane time and time again, consistently, precisely, and without question. So that was your 45-minute rundown of hyperfocal focus. It was quick, but we did do, we had a chance to do a demo on the camera with my inventive proxy for a landscape shoot. And I hope that the slides really clarified some of the surrounding things you need to be aware of when you're thinking about hyperfocal focus. The depth of field, of course, but then also diffraction, and then also understanding what is the intended final result for this image. Is it going to be a big print? Is it going to be a small print? What is acceptably sharp? If you're shooting with a 101 megapixel digital back and you only intend to print an 8x10, I can tell you you don't need to worry about the things in the foreground being a little bit soft. You're going to scale everything down, everything's going to look tack sharp anyway. So that's that, you know, be aware of the intended result. What is acceptably sharp given my intent for this image? So, David, how you doing with questions? Did I talk too fast?
No, I think you explained it so well.
Oh, I hope so.
That everybody is pretty clear on the result. I've just got a question from Craig and Farron. Hi, Farron. David, is it possible to do this without a lens align perhaps and a real world shot into the mountains? So if you were doing this for real, not in the office in Copenhagen, how would you do it?
Yeah, so that's a great question. The lens align here is just for demonstration purposes. It's just so I can show it to you very, very clearly. This is not something that I would bring out into the field, the lens align focus tab. I would simply go out to any landscape and I would first focus at infinity, and then I would start to move the lens back until I see my loss of infinity. Once you see the lens is moving in the correct direction, it's moving towards a nearer focus. Once I see infinity start to get soft, I know that my hyperfocal has moved too far forward. So, of course, don't use a lens align when you're out in the field. Just use infinity and walk the lens slowly forward until you see infinity start to get soft, and then you know you've gone too far, and find that perfectly calibrated point in between. Like we just did in the demonstration, where you can't tell the difference between one image and the next when you're shooting at infinity, but you can see that between one and the next, you get more foreground focus. I mean, I would suggest you don't have a lake or something very flat and plain as your foreground. A field with grass would be perfect, because you can see the individual blades of grass kind of come into focus. So real world applications, don't worry about the lens calibration. Just, you know, go out there, shoot infinity, and make sure that you've got some subject matter that you can keep an eye on.
Nice. Couple of other chart-related questions. Do we have a chart? Farhan is asking that describes the sweet f-spot for infinity with minimum diffraction for each of our lenses, or is it pretty consistent?
No, it's going to depend on a lot of different variables. We're not going to put out, you know, a specific, this lens with this digital back at this focusing point, this is the best combination, because there's too many variables. You really need to do all of those tests on your own and understand that the higher resolution your digital back is, the less flexibility you're going to have in your aperture. So with this particular lens, the 35, I find that when I'm trying to get infinity focus in there, I'm somewhere around f9. That's my sweet spot. But if I focus closer, if I use a lower resolution digital back, even if I just tilt the camera down, then I'm going to have a different aperture that's going to give me different results. So sweet spot is not, it's a term it's the sweet spot for you and your given application. It's not a hard and fast rule for every single lens on every single digital back. I hope that helps.
Certainly does, certainly does. The other chart question was, Steve was asking, do we have one that shows the focus ranges compared to different apertures? So for example, he says 35 LS lens at f11, like what's the hyperfocal focus of that particular lens, for example?
Yeah, so that's really going to be what this is right here. So on the actual camera itself, this is what you're looking for. That guide is your approximate hyperfocal guide. So that guide on top of every lens is really what you should be looking at for your, again, your approximation. That'll get you in the ballpark. And then from there, you're going to have to do the calibration to get those precise results. So the guide, the hyperfocal guide, is a legacy from the film days, but it gets you in the same area. The hyperfocal calibration tool in the XF is what really nails it down for you, so that it is, without a doubt, consistent time and time again, no question about it, and it gets you the perfect hyperfocal focus. What else you got for me, David?
And Farron is also asking, can we have multiple hyperfocals for each lens? For example, say one for landscape where you want to have near focus to infinity, and then one for studio, or Steve was always asking for, interior shots where he's not at infinity, but he still needs a broad depth of field.
Yeah, well, I mean, you can certainly do that on your own. You can find a calibration, a hyperfocal focus point calibration, and just write it down and keep a note of what it is. But the camera itself can only save 1 point per lens. So it can't have multiple points per lens. It's 1 point per lens.
Okay, and does it work for zoom lenses? Sue Brutta was asking.
Excellent question. Yes, it does work for zoom lenses, but just like it's not intelligently linked to know what aperture you're using, it's not going to know which focal length you're using on a zoom lens. So what you would want to do is either calibrate it at a zoom that you use, focal length that you use on that zoom all the time, or one that's a bit more forgiving. Something that's in kind of the middle with a bit of depth of field still behind infinity, so that you can use it throughout the range of your zoom without fear of it actually, the hyperfocal point moving in front of infinity focus and you getting a soft infinity. So just be a bit more forgiving when you're calibrating it if you have it on a zoom lens. And again, when you're calibrating it, just test it with the widest and test it with the most tele or normal focal length on that zoom. Is that it, David?
Nope, not yet. Yeah, not off the hook yet.
Fair job security.
Keith was asking, has the latest firmware allowed the hyperfocal to remain active when the camera goes to sleep? I mean, I assume it should be remaining active until you disable it.
Yeah, the hyperfocal, you can assign it to a button if you always want it to be there. And having it on a focus mode, if the camera goes to sleep, it will default back to autofocus. So like a normal autofocus mode instead of the hyperfocal focus. So if you want to have it all the time, you simply assign it to a button so that it's always available. And if you have it in a studio, then you just power the camera and don't let it go to sleep. And you're all set.
Cool. I asked you the question about zoom lenses, didn't I?
Yes, you did.
Okay.
And I gave an excellent answer to it. I'm surprised you don't remember.
I'm sure you did.
Hurt.
Will there be ever more than 1 point per lens to save, do you think?
It's possible. I mean, something like that does require us to have, use memory in the XF camera system that could be used for something else. But it also requires us to build kind of an interface for how would you choose which one at the right time, labeling it, not getting it confused. So there could be, certainly, and if it's something that you absolutely must have in your XF camera system, be sure to contact our support department and put in a feature request. Once we know the demand of that, we'll be able to evaluate it, and if it's something everybody's asking for, then of course we'll be there to put it in.
Great stuff. I think that's pretty much it, Drew. The last one really is, this is going to be on YouTube in what, within 7 days, something like that?
Yeah, I'm hoping it's going to be on there this weekend. So look forward.
Perfect.
There was one question from this morning's webinar that I think was a very good one. Someone had just asked, why would I use the hyperfocus point and depth of field as opposed to focus stacking? And it is a very good point. They are two different things that are trying to achieve similar results. When you use a hyperfocal focus, you're taking one shot and you're getting as much out of your depth of field as possible, but you're introducing that acceptable sharpness and a depth of field roll off. And so you might not get everything perfectly tack sharp. Again, depth of field does not have a hard start and a hard end. It gently rolls into focus and rolls out of focus. So the hyperfocal focus is the best way to take advantage of depth of field as much as possible and really make it work for you. Whereas focus stacking is something where if everything needs to be absolutely tack sharp, then you would use focus stacking. But it has its disadvantages too, where you can't have moving subjects when you're focus stacking. It does require a bit more of post-processing work where you have to take all the images, combine them in Helicon Focus, and then you're left with a linear TIFF file. So there's trade-offs to both, but just understand that this hyperfocal focus shouldn't replace focus stacking. If absolute tack sharp images from beginning to end with no question about that acceptable sharpness, then you should use focus stacking. But if it's one shot out in the field and you want to get as much out of your depth of field as possible, hyperfocal focus is what's there for you. So that brings us up to just about an hour. Thanks everybody for hanging in there. I hope I clarified a few things for you if you had any questions, and I hope you understand how the calibration works and kind of the things you need to think about when you're looking at hyperfocal focus. Depth of field, diffraction, and acceptable sharpness with your final output intent. So if nothing else, I hope you learned something today, or had a good chuckle at my expense. And yeah, thanks for coming. We hope to see you again at the next one.